start this class. Yeah. Today we will talk about Fourier series properties too. Yeah, actually we have already talked about some properties, and we will continue to talk about that. And this is today's goal. First, we will review FS signals analysis and too often used Fourier series pairs. And then we will review the symmetric properties of Fourier series. Actually, last Friday we talked about symmetric properties of Fourier series. And today we will try to learn linearity and time shifting property and try to use those two to like simplify the computation of FX coefficients. Yeah, all the properties, all the Fourier series properties, it just help you to easily get the Fourier FS coefficient or FS like a synthesis like that. Yeah. Okay, let's try to review the Fourier series analysis. Yeah. Okay. Let's try to start from the start from the beginning. Like we know this is a periodic signal, am I right? Yeah. If you represent a signal xt equal xt plus, what's the period? Yeah, the capital T, big T. Yeah, and this is like a fundamental frequency, 2 pi over T. Yeah, am I right? Yeah, this is just a frequency equation. And actually, we can try to represent the like different like frequency using this in this form. Do you remember the polar representation? Yeah, this is just the polar representation form. Yeah, to represent the different frequency thing. Yeah, and then you can see this one. We can try to then this is just the fundamental item, and after you add a key, this is just a different like a different like a component. Yeah. Do you remember like this key is just a similar like the 3D vector. This is just a one key equals 0, one key equal like 1 key equal 2, one key equal like maybe 3, yeah, it will be difficult to represent him, but it's just that meaning, like geometric meaning. Yeah, in the like using polar representation representation thing. Yeah. Okay. And then this is just like what's the name for this one? What's the equation? Yeah, the like a signal analysis. This is just like try to use this equation to represent your FS coefficient. Yeah. And then if you have FS coefficient, you will, like we call it a signal analysis, you will have FS like signals, am I right? Yeah, you can use the AK to represent the original signal. Yeah, we just talk about that. This is just like the like Fourier series representation for signals. Yeah. Okay. Let me talk. Let me ask you. Actually, we talk about when we represent a signal in time domain, which means you just try to like these signals will change by the time. Am I right? For example, at plus b is all. Where is the like the yeah, like that. Yeah, we will like try to represent a signal at like b all like 1 equal at squared plus abt plus c. Yeah, this is the other like system and signals. Am I right? Yeah, you will see that this signal always change by the time. Am I right? Yeah, but here actually you will consider the key omega naught t as a total, as a whole, as a like a whole thing. Actually, this part, yeah, you will know it's just like this part. This part is just similar like the not similar. You can represent this part in a polar representation, am I right? Yeah, and actually those whole part is just a frequency item. You will see like your signal will change, but this part change. That makes sense to you? Am I right? Yeah. So this is just like the frequency part. We call this is the frequency item. Yeah, then you can see the original signal will be represented in a frequency, like in a frequency domain. That makes sense to you? Yeah. Okay. And this is, we call it signal synthesis. Okay, and then you can see actually those two signals is same signal. Yeah, this is just like the time domain, like a representation like that. And this is just the frequency domain representation. That makes sense to you? Yeah. Okay. Any questions so far? This is just yeah. And okay. And then we talk about two often used FS pairs. Actually, this we talk about in last Wednesday. Yeah. Like I talk about why we these two FS those two signals are very important for us because we will use those two and the like Fourier series properties together to simplify the computation for the Fourier series coefficient. Yeah, and these signals, and let's try to recall what are the frequency like FS coefficients for those two signals. And the first signals, yeah, we represent the signals like this. Yeah, this is just the representation. Yeah, like the time domain. Yeah, and what do you remember? What's the FS coefficient? Yeah, actually, yeah, the FS coefficient will equal this one, which means what does that mean? Which means the A key, no matter key is what, and the coefficient, the FS coefficient is the same, always 1/t. Am I right? And when you have the midterm 3, just put this in your cheat sheet. Yeah, because this one is very important. Yeah, and then the next one. Yeah, we know like we talk about because for this one your p equals 0 is A0 is 1/t. But this one you need to like calculate the A0 and the other key separate because for this one the A key equal this like this is the equation for A key, but you can see you cannot let the key equal 0 for this equation. Yeah, so the A key should be like A0 should be calculated separately. Just use like this equation. Yeah, when the k equals 0, which means this part will be 0, like 0, and the xt is just a 1. Am I right? So you just try to like integral this part. This is just the area this part and divide t. The area this part is just a 2t1 multiple 1. Am I right? 2t1. So it's just, and then actually the the A0 is just the standard area divided period. What's the standard area? This area is just all the in one period is all positive, am I right? But for some figure, the area is not like always positive. It will like half positive, half negative. You need to like calculate the standard area. Yeah, we will talk about later. But just remember this for this signal, the FS coefficient is this one. Yeah, those two like signals are very important for us because you can use those two to and FS properties to simplify the computation for the like FS coefficient for any other like signals. Okay, any question? Yeah, if you want to know how to calculate it, you can review the class video or slides before. Actually, you just use this equation, and then you will find you can get this result. Yeah. Okay. And then let's try to talk about that. Find the signal average. Actually, if you the signal average is just usually we calculate for A0. Yeah, because for some equations you can for some many signals you cannot using this equation to calculate in A0 because usually there will be a key in the like friction below, and then you cannot let the key equal 0. So you need to separately calculate it. And then usually the A0 equals standard area divide t. What's the standard area? you can see for this one, the sand area is just positive, am I right? For in one period, yeah, it's just like a 2T1, am I right? But for this one, this the period is from one period is from here to here, am I right? This yeah, this is one period. That makes sense to you. But what's the sand area? Yeah, the sand area, which means this part and this part. That makes sense to you? Yeah, and what's the sand? The sand area, which means the area will be added, this area and this area will be added together. Yeah, it will be 0. That makes sense to you? Yeah. Okay, and let's talk about this one. What's this is just one period, am I right? Yeah, what's the area? Are you sure? Yeah. No, this is not 3. Like this is this whole area. Yeah, because this is one period, am I right? So this is 4, am I right? This is 2, am I right? Like for this is 1/2 divided like 2 over 4 divided 1, am I right? Divided 2, am I right? What's the area for this shape? Do you remember? I think it is yeah, over 2. Huh? Is that right? And then divided time divided like a period is 4, am I right? So which means it is 1/2. Like let us calculate it. This yeah this area, like this is 4, am I right? This is 2, am I right? So which is this area is 12 divided, am I right? Yeah. No. Oh no.
Very plus.
Huh?
Oh, it was one of the bases.
Yeah.
Base 1 plus base 2 divided by the height.
Oh yeah, but height is 1, am I right? Okay. Yeah. Oh, it's a base multiple height divided 2, am I right? Yeah. That makes sense. Is that right? Yeah. This is like yeah. I also forgot that. I think this one is a very common, like yeah. Yeah. It's just like a. Let me see. Oh yeah. Oh, this one. Sorry. It is 4 plus 2 multiple 1 divide 2. Yeah. This one plus this one multiple height divide 2. Yeah. Yeah. And then this is like 6, 3. I'm right. 3. And the period is 4, right? So I think the A0 should be 3/4. Okay. I think this number this value is not right. Okay, sorry. Give me for a moment. Yeah, it is. Let me try to eraser. Yeah. So yeah, this is 4. I'm right. And 4 and 2. Yeah. Multiple 1 divide 2, 3. Yeah. This is the right answer. Yeah, that makes sense to you. Yeah, I think this one I will modify that. And for this one, how about this one? This is just the like the base multiple height divide 2. Yeah, this one is the base is 1, 2, 3. Multiple height is 2. I'm right. 6 and 3 divided 3 is 1. That makes sense to you? Yeah. So how about this one? Yeah. This one, I think it's a tricky one. And the period, let's find the period. What's the period? Period is 2, am I right? Yeah. This is just one period, am I right? That makes sense to you? And then, which means like this is just like a one, and this is just if you try to get the period, this is one and this is -2, am I right? Do you remember what's the value? What's the value for the input? Do you remember if we have an impulse, what's the value? What's the area? Area means we just try to interpret this part, and for if it is one, this will be one, right? And if that for this part, for this part, the area should be one, am I right? And for this part, the area should be 2. Does it make sense to you? But this is negative. So if you plus them together, it is -1, am I right? But the period is 2, am I right? So it's -1 divided 2, yeah. That makes sense to you? Okay. And then let's try to, yeah, what's a period? Period is just include 2 different area, am I right? And yeah, what's the area? I think this one is easy. For this area, it is just 1 by 1. That makes sense to you? And this area is also 1 by 1, but this one is negative. Yeah, this is 0. That makes sense to you? Okay. And how about this one? Yeah, this is just a 1 period, and which means you just it compare this area and this area. This area is 1, am I right? And this area is 2, am I right? So it's 3, and the period is 2. So 3. Eh?
Yeah.
Huh? Oh, yeah. Sorry. You're right. Like I just forgot that the period is just like you can see the period should yeah. I think you talk about the right. The period should from here to here. This is just the start period. This is end period. So this is just 3/3. That makes sense to you? Yeah. You're right. Yeah, I just missed that. Okay. Then I think this one also right, because this is just like from -2 to 4. Am I right? So which means it's 6. And the area is also 6. Yeah, 3/6. So it's 1/2. Yeah. Sorry, I missed that. Yeah. Yeah, you're right. Okay. Any questions so far? Okay, yeah. So, this like a page, this slide just tell you if we want to calculate A now, what should we do? Yeah, but the A key is just like you use this equation. Yeah, that makes sense to you? Okay. Yeah. Okay, let's continue. Okay. Then let's review the things we have already learned in last class. The symmetry property summary. Yeah. Actually, for the like fs coefficient, like we have some symmetry property, and why we call it symmetric? Yeah, because it's kind of like the first thing is your signal is must a symmetric signal. Yeah, and then you can see the symmetric property, like you will find there are some like symmetric features. Yeah. Okay. This is just if your signal is a real signal. What does a real signal mean? Do you know? Yeah, I have already given it to you. If let me ask you, if a number is a real number, you can see if we want to represent any number, we use A plus BG, am I right? Any number. That makes sense to you? If a number is a real number, what does that mean? This is any number, am I right? Yeah, if the number is real number, what does it mean? Which means the number the number doesn't have imaginary part. Am I right? So which means the B equals 0. That makes sense to you. Am I right? So this is let me define this in X. Am I right? And if the x star, we know it is equal bg, right? Yeah, usually we just represent one any number, this one, this is the conjugate number, right? If this number equal this number, if this one, if those two equal with together. Yeah, what does that mean? A can be removed, right? Yeah, so because A equal A, yeah, we know that. Which means if you want those two equal together, Bg should equal negative Bg, right? So in what condition Bg will equal negative Bg? Which means in what condition B will equal negative B? You know? In what condition B will equal negative B? When B will equal negative B? Huh? Imaginary? Yeah, this is the imaginary part. Yeah, but we want this one equal this one, right? If we want this one equal this one, which means this part will equal this part, which means B should equal negative B, right? In what condition B will equal negative B? If B, let me ask you, if B equal 1, what's negative B? Negative 1, right? Yeah, obvious. If negative 1 equal negative, if 1, does 1 equal negative 1? No, right? Yeah, if B equal negative 1, negative 1, negative B will equal 1, right? Does those two equal with each other? Do they? No. So when B will equal negative B? Are you sure? Never. Never? No, not that. Yeah, actually there is one number.
0.
Yeah. Am I right? Yeah, when B equals 0. Am I right? So that's the reason when x equal x conjugate, which means the x will be a real number. That makes sense to you? Yeah, that's the reason why here, if we talk about this signal is a real signal, which means the xt equal x conjugate t. That makes sense to you? Yeah, and then let's define the x t, the fs coefficient is ak. Yeah, we just consider it is ak, and then the ak should equal a negative k conjugate. Yeah, that makes sense to you. Actually, we improve improve like in last class. If you like, if you want to yeah, this is just the result. Yeah, okay. And let's try to, yeah, we call it a conjugate symmetric. Yeah, okay. Okay, and then let's talk time reversal. If we have a signal xt, and the ak is xt's fs coefficient, and the bk is x negative t the fs coefficient, and then we have bk equal a negative k. Yeah. Okay. Let me ask you one question. For example, AK, we know it is a conjugate number thing. Yeah. And if AK equal let's just x plus YD, what is AK conjugate?
Science.
Yeah, x minus YD. And what is K? Negative A negative K. Yeah. So you should firstly you should do this one, and then let's talk about this one. Yeah. So BK will equal A negative K. Yeah, this is just the result. This is just conclusion. We just improve it, like prove it, like in last class. If you you review, and then what does that mean? Which means if I know the xt is the fs coefficient, I can easily to get X negative T's FS coefficient based on this property. That makes sense to you? Yeah, okay. If one signal is even signal, yeah, xt equal x negative T, we know this is an even signal, am I right? And then we will have a key equal a negative key. Yeah, and then let us talk about one thing. Here, this xt signal, just remember, it's any signal. I didn't tell you if it is real or not, or like complex, am I right? Yeah, so this is just any signal. Yeah, only if this signal is even, and then a key will equal a negative key. Yeah, okay. And we call it even FS coefficients, which means that the a key has the even relationship. Yeah, okay. And then if this signal is odd signal, and then this is just the definition for odd signal, am I right? So the a key should equal a negative key. We call it odd FS coefficients. Yeah, and then we have a very important conclusion. If your signal is real and even, which means this one equal this one and equal this one. Yeah, because this one is just, it is even. And this is just, it is real, which means this is real and even. And then what's the result? What's the conclusion? Which means this one will work, and also this one will work. That makes sense to you? Which means those three will equal each other. Am I right? Yeah, and then yeah, real, we call that, we know like the FS coefficient is also real and even. Do you know why? Yeah, because you can see if a key equal a negative key. Yeah, which means it is odd. Am I right? Which means it is like a even. Am I right? Because it is just like a flip, like a even like it's just like a symmetric. Am I right? And if a key like a key equal a negative conjugate, yeah, a conjugate equal negative. Am I right? Which means it is just a real, yeah, this one. If this one equal this one, yeah, a key equal a negative key, yeah, which means it will be real number, real like yeah, that makes sense to you? Okay, and then if your signal is real and odd, which means you will have this property. Those three will equal with each other, and then it is imaginary and odd. You're like AK will imaginary and odd. Yeah, that makes sense to you? Okay. And then this is, we have already prove it like in last class if you want to review it. Yeah. Actually, you can see if you know the signal, if you know like your FS coefficient have this property, you will know your signal is real and even. Am I right? If you know your FS coefficient have this property, which means your like a signal will real and odd. Yeah, it will help you to judge, like to decide your original signal is what kind of signal, like that. Okay, let's try to check one example. If we can represent a real signal xt by its even and odd part as this equation, yeah, we can definitely, yeah, this is our equation. Actually, we talk about in chapter 1, if you remember that. Find the FS coefficient for x, like for this part, and for this one and this one. Okay, yeah, and we know this is real signal, am I right? So what does that mean? Which means if we know like the AK is FS coefficient, and then AK equal a negative K conjugate because it's real, am I right? That makes sense to you? And then the A negative T, we know it is a negative K. Yeah, based on yeah, this one, am I right? A negative K. Yeah, and then yeah, because this like yeah, it is equal a K conjugate. Do you know why? Do you know why this with this one? We know like we know like the if xt the fs coefficient is this one, and since this is a real number, we know it's a real signal, so we know a key equal a negative key conjugate, am I right? And then for the x negative t, we know like the coefficient is a negative key. Yeah, since the property we have already learned. And but why this one equal this one? Actually, it's very easy. You can see you just replace key with the negative key in this equation. Then this is a negative key equal a key conjugate. Yeah, it's just the same with this one. That makes sense to you? Yeah. Okay. And then like xe, if we know like xe is this one, signal is this one. Actually, then the like a key equal this one because the a it's linear system. Yeah. So and then this one we call it the a key, real a key. Do you know why? The a key is real part. Do you know why this equation? Let's we know like a key equal x plus yg, am I right? ig or yg, it's the same thing. Yeah, sometimes it is. Yeah, and a key conjugate is what?
X minus.
Yg, am I right? Yeah, then a key plus a key conjugate equal what? 2x divided 2 is x. That's the reason why it's a real a key. Yeah, because you can see it's just the real part for a key. That makes sense to you? Yeah. Okay. And then for the odd, we know it's equal this one, am I right? And then we define it as imaginary part. Yeah, do you know why? Yeah, it's the same thing. You just divide it. Then you will see. Yeah, so just get it. Yeah. 2 that like minus a key conjugate equal like 2 yg and right divide 2 something. It is yg. Am I right? So this is just the imaginary part. That makes sense to you? Yeah. So so we know like the xt, any signals can be divided into two different parts, even part and odd part. Yeah, we have already learned this in chapter 1. And you can see for the AK, it also can be like divided into two different parts, the imaginary part and the like a real part. And you can see for the real part, it's just the fs coefficient for the even signal. And for the imaginary part, it's just the fs coefficient for the odd part. Yeah, so what does that mean? When you try to analyze a signal, and you can see, you just try to, you get the even part and you get the odd part. The even part always related to the real part, real like coefficient. And the odd part will always relate to the imaginary part for the AK. Yeah. So let's talk about some examples to determine the real imaginary complex even odd properties for the following signals. Yeah, this is for the first one. Do you know like what's the like fs coefficient? What's the like yeah? What's the like is this what's kind of like signals? It is real, or it is imaginary, or it is complex, or it is even, or it is odd. Yeah, let's try to. Yeah, you can see here. The key is from -100 to 10. Am I right? It's now symmetric. Those kind of like signal, it must be complex signal because it has a non-symmetric bonds, which means it must have like a complex part. Yeah, just remember that. Okay, and for this signal, how about this signal? Huh? Yeah, the AK is imaginary. Yeah, because this part is AKM, right? Yeah, and AK is imaginary. You have already observed. Is AK is like even or odd? Yeah, actually, you can see this part is now will not affect. Am I right? Yeah, this G is just tell us the AK is imaginary. Am I right? And this part is just like a number. It's like must be a positive number. Am I right? And this part sen function. What does sen function look like? No matter this sen function, what it must be look like this one, right? This, right? So it is odd or even. What does that mean? Even mean? Even means the xt will equal x negative t. Am I right? So this the odd, which means the like xt will equal negative x negative t. Yeah, so it is odd. So which means AK is imaginary and odd. Am I right? Let's try check here. If your AK is imaginary and odd, what does that mean? Which means your signal is real and odd. Am I right? Yeah, so just try to check this. Yeah, and you can easily to tell. This is yeah, since AK is imaginary and odd, and your signal is real and odd. That makes sense to you? Yeah. Okay, let's try to check this one. Firstly, we check the boundary is symmetric. Yeah, that's okay. And we know this is AK, am I right? So AK, if AK is imaginary or real, yeah, it is real, and it is even or odd. Yeah, it is even. So which means AK is real and even, which means the signal is also real and even. That makes sense to you? Yeah. So we can easily to tell what kind of this signal based on the AK. Yeah. Any questions so far? Okay. And then let's talk about the other property and linearity and time shifting property. Linearity, which means we have two different signals, xt and yt. Yeah, they don't have any relationship. That's two different signals. And then we know like the AK is ft is fs coefficient and the bk is yt is fs coefficient. And then if you have if you have a new signal axt plus byt, then you will have then the fs coefficient for this signal will be this one aak and plus bk. Yeah, this is just the linearity property. Actually, we have already used the linearity property just now in this equation. You can see this part we use. Yeah, because you can see this one like it's just a is it. This is just a yt, right? It's divide 2 is half. A is half and b is half, like this, right? Yeah, so it's just a multiple them together, plus them together. Yeah, this is we call it a linearity property. That makes sense to you? Yeah. And then let's check the time shifting property. Time shifting property is which means we have a signal st, the fs coefficient is ak, and then for the xt minus t0, and we have the bk is the fs coefficient, and the bk will equal ak multiple e negative gk of that now t now, which means it will have you have a shift in time domain. You will have a shift in like a frequency domain. That makes sense to you? You will have a like shift in frequency for this one. Yeah, that makes sense to you? Yeah. Okay. And then this part we call it linear phase shift. Yeah, you have this like a phase shift. Yeah. Okay. Any questions so far? Yeah, this is just like the linear and time shift property. And let's check one problem. And for example, for a real signal, xt can be represented as a sum of even and odd part, like this one, and this below is just similar. For a time reversal signal, yeah, we have the fs coefficient is this one, and we have already talked about that. And also we have for real signals, we have this one, and also here we have to talk about that, and which means this x for the x negative t, if your signal is like a real signal, and the x negative t will be the fs coefficient will equal this one, bk. That's a combine them those two together, and then the xe t, yeah, we have this one, and this is the real part, and for the all part, yeah, actually in this example. It's just what we talked about just now. Yeah, because this one here, it does use the linear property, linearity property. Am I right? Yeah. Okay. Any questions so far? Okay. And then let's try to do a deep look for the linear phase shift. Yeah, we know if you have this signal, and then your AK will become this one. Your fs coefficient will have a shift, am I right? And then this one will equal this one, because omega naught equal 2 pi over t. Yeah, we know that, am I right? Yeah, the frequency equal 2 pi over period. Okay, and then let's talk about this part, t 2 pi. This is just the phase shift of key order harmonics, which means for key order, this is the phase shift for different key, am I right? And then this is just this number of period of key, and the period of key order harmonics. Yeah, actually, for the number of period of key order harmonics, we just divide it 2 pi, just try to change it to the angle. And then this is the period of key order we talk about in chapter 2. The for key chapter 3, yeah, in the beginning. If we want to for the specific key, and the period will equal t over k. Do you remember? Yeah. Do you remember? Yeah. And this is just the change this divide this part with 2k, and it will change to the time like that. And after you multiple those two, and you will find it will equal t now, because you can see t 2 pi over t is what? It's omega now, am I right? T over 2 pi is what? 1 over omega now, am I right? It's just omega now multiple, one over, it will be removed, am I right? And then this k and k will be removed, and this t, this part, this equation will equal t now, am I right? Oh, okay. And what does this mean? This means if you do a phase shift for the specific key order, am I right? Actually, in the time domain, it's just the same shift. That makes sense to you? Yeah, you can see. Let's just review that. You can see you shift the signal in time domain with t0, am I right? Am I right? The signal will try to along the t-axis move to left or right. Here but for the Franks domain, for the specific key, actually you just shift different value, am I right? But for the different key, you just shift the same time. That makes sense to you? Yeah. That's just a deep look for the linear phase shift. Any questions so far? Okay, and then let's try to review one problem. Yeah, this one. Actually, we have already talked about this one. Yeah, XT. We know and this is the GT. Actually, this is that two common used. And we know this is the FX coefficient for the GT, am I right? And then for the XT, the period is 2, am I right? Yeah, and then actually the xt equal what? I should not, yeah, the xt, actually you can represent xt with gt. Am I right? Yeah, actually I just give it to you. Yeah, the xt equal gt minus 2. Yeah, you can see this is gt. Am I right? And here t is 2. Am I right? Yeah, and 2gt minus 1. Actually, which means this is just like a shift to right, am I right? To right 1, like this. And then multiple 2, negative 2, it will like just like this, and add them together. Am I right? It's just a similar, it's just become this one. Does that make sense to you? Yeah, which means it's just a shift 1 and then multiple negative 2 and then plus the original one. It's just this one. That makes sense to you? Flip? Yeah, multiple by 2 and then add. Yeah, you can see. Let me yeah, for here, yeah, you can see t, the gt is equal this one, am I right? And this from here we just get t equal 2, am I right? So which means this is 0, this is 2. For this one is 2, am I right? So which means for the gt, it is this 0 is 1, 2, 2, and this is here. This is gt, am I right? And for the gt minus 1, which means it will right shift 1, right? So which means this one will shift here 1, right? And this will shift to 3, right? That makes sense to you? And then it will like multiple negative 2, which means it will become this one, and this one, and become like this is 1, become this one, am I right? Yeah, so then it will add with the original one, which means you just like add here, and here, yeah, and it's just the same with xt. That makes sense to you? Yeah, so which means you get this one, and we know like from the linear property, we have this one. That makes sense to you? So we have already know GT's fs coefficient, which means the GT, the fs coefficient is 1/2. Am I right? When the when the like k equals 0, and this is 1. This is this one. Yeah, because you can see why the fs this one t equal 2. Am I right? So the ak for the gt, like the fs coefficient 1/2. Am I right? And for the like gt minus 1, here. For the gt minus 1, it is what? It is the ak 1/2 and multiple this part. That makes sense to you? Yeah, which means we will multiple this part, and this t now equal 1, am I right? Yeah, so that makes sense to you? And also this is 2 and this 2. And this is just the ak, am I right? This is just because you have a shift. Yeah, so time shift, so you have a free shift here for ak. And then this equal this one. That makes sense to you? And then based on the linear, yeah, this one equal this one. Yeah, it's just like a Euler equation. Yeah, and then equal this one. And from the linear property, you will have the fs coefficient for the st. That makes sense to you? Yeah, you can see if you know some properties and you know this like fs coefficient for this signal, you can easily to get this one. Am I right? Okay. Yeah, we will talk about more about this property next class. Okay. Any questions? Okay. Yeah, just use some existed thing. Yeah. Okay.